So today we're going to cover section 8. It's on coordinate proofs. It is the last lesson in this chapter. So your test is Tuesday. So after today, Friday and Monday, we're going to start reviewing for your test. The test is on all of chapter 5. However, the focus will be more towards the end and on those 5 shortcuts as well as that CPCTC. So to do a coordinate proof, what we're going to be doing is we're going to be placing geometric figures in a coordinate plane. And then instead of giving their coordinates or their corners or their vertices as actual numbers, we're going to give their vertices as variables. This way, no matter what the length of, say, a rectangle is or the width, it would work for every single rectangle type by putting in a variable as the coordinates. So that's why the results would be true for all figures of that type. Okay, so in the first example, they want us to place a rectangle in a coordinate plane so its vertical side, so the side up and down, has a length of A, and its horizontal side has a width of 2A. And then it wants us to label the coordinates of each vertex. Now, you can choose how long or how many squares A represents. I'm going to go ahead and say, for me, A is going to be 2 boxes long. So what I'm going to do is I'm going to go ahead and label A right here. And this is going to be the order pair of 0, A. Any order pair on that y-axis, the first number is always 0 and then whatever the number is. And in this case, it had a length of A. My other vertice or my other corner of my vertex, I'm always going to place here at 0, 0. 0, 0 is always a nice placement when you're putting a geometric figure into a coordinate plane. Now, the next part said that it has a side length, and its horizontal side has a width of 2A. Well, if I made A 2 boxes, then I'm going to make 2A 4 boxes. So this would be 2A, 0. Whenever your order pair is on the x-axis, it's always whatever the number is, 0. And now I need to get that last corner of my rectangle. So I'll put the point right above here. And then this order pair, I take the x of this one, so 2A, because that's how many I went to the right, and then I went up A. So that's the coordinate 2A, 2A, A. I could connect my points, and you can see that it forms a rectangle. So this is how you could place a rectangle in a coordinate plane when they give you how long they want the side to be, the horizontal side and the vertical side. Let's try example 2. We're going to be placing a square. And again, the best placement when you're placing a rectangle or a square is to put one of the vertices down there at 0, 0. So I want to place a square in my coordinate plane, and it tells me it has a side length of n. So again, when it's a square, we know all sides are the same. So we can figure out our fixed length for n. Let's say it's 4 boxes. You could go as many as you want. So this is going to have a length of n. And then it's also 1, 2, 3, 4. It'll be n in this direction. So here would be my coordinate. Let me write this so you can see it. So this is the order pair 0, n. And then this point right here is n, 0. And then the missing corner, this would be n, n. I can connect the points, also get your other corner in here at the 0, 0. Now, it wants me to find the length of the diagonal now. So let me go ahead and label, I'm going to say this 0, 0 point here. I'm going to call this point A, just so you have a reference, and I'll call this one C. So really what I want to do is find the length of the diagonal, and that's from A to C. So I'm going to find the length of AC. So my ordered pair for A is 0, 0. My ordered pair for C is NN. I'm going to use the distance formula. So n minus 0 squared plus n minus 0 squared, square n, square n. This gives me 2n squared, and it's under a square root. Whenever you square root variables, it's like dividing the exponent by the index, and the index on a square root is a 2. So really I'm dividing 2 by 2. That makes the n come out. The 2 is not a perfect square, leave it underneath. So the diagonal length is n square root 2 units long. So underneath the radical initially is just 2n squared. But whenever you square root a variable that has an exponent, you divide it by the index. And in this case, when it's a square root, you divide it by 2. So really what I did was I took n squared, I divided the exponent by 2, which gave me n to the first, which comes out of the radical. This is all Algebra 1 skills. Here the diagonal length is n times the square root of 2 units long. Now example 3, we're going to be finding the slope, the length, and the midpoint. And then we're going to go back and use that information to see what kind of triangle we have. Everybody ready for example 3? Example 2. All right, example 3, it says to sketch DEF, it wants me to find the slope of each of the lines, the length, and the midpoint. And then after I do those 3 things, I have to decide, is my triangle right and is it isosceles? So let's go ahead and put these in. So I'm going to graph the ordered pairs. So remember, whenever the 0 is first in your ordered pair, that's going to be on your y-axis. So I could graph the ordered pair. I'm going to say n, again, it's going to be 4 spaces up, just like I did for the square. So this is the ordered pair. I'll do it on it so you can see it better. 0, n. And then f. I'll put it over here. 1, 2, 3, 4, 5, 6. I'll say it's out here. This is F, and it's going to be M0. And then lastly, E, it's going to be MN. So directly above the red one and directly across from the blue one. MN. Connect the points. Here's your triangle. Now, first glance, you're going to say, oh, that looks like a right angle there. However, we have to confirm that by calculating the slope. Once we find the slope of the line, if they're opposite reciprocals, then we know it's perpendicular, and then we know it forms a right angle. However, in this case, the 2 lines are vertical and horizontal, and you should automatically know that a horizontal line and a vertical line together are perpendicular. But we're going to do the slope, and we're going to see that it's undefined and 0, and that tells me that they're perpendicular. So let's work with DE first. So the first thing I'm going to do is find the length of DE. And then I just have to come over here, and I can see that it only went up to here, which was M, so it's M units long. Then for the slope, DE is a horizontal line, so the slope equals 0. Then for the midpoint, now the two coordinates I'm using here are 0, n and m, n. So for the midpoint, I add the x's, divide by 2, add the y's, divide by 2. So this gives me m over 2, and this gives me 2n over 2. The 2's cancel, so the midpoint is m over 2, n. That's your midpoint of this line. Now let's do EF. So for the length, I can just see that it went up to n. So the length is n. The slope, it's vertical, so it's undefined. And then for the midpoint, I'm going to take the x's and add them. So m plus m divide by 2 and n plus 0 divide by 2. 2m over 2, n over 2. These simplify. So the midpoint here is m, n over 2. Now, right at this point, without going any further, I can see that the slope of EF along with the slope of DE, these are opposites. So this makes DE perpendicular to EF. So this indeed is a right angle here. So far I know that this is a right triangle. Next, I need to find that last missing side to see if it's isosceles, scalene, or equilateral. Obviously, it's not equilateral because I already have two different sides. And also, another thing you should realize is this is the hypotenuse, and it's always the biggest side. So it's not going to be isosceles because that would mean the two legs had to be the same ones. But let's do the distance and calculate the slope and everything for this last side. So I now need to do all of it for DF. And D is 0n, F is m0. So let's go ahead and do the length first. I can't count boxes or anything or look at the numbers, so I actually have to do the distance formula. So m minus 0 squared plus 0 minus n squared, m squared plus negative n squared is just n squared. So that's the distance. So the length of DF is this. Notice it does not match any of the other numbers. So that is the answer to my question. This is a right scalene. It is not isosceles because all the lengths were different. But let's just practice finding the slope. So again, using the same order pairs, subtract the y's, subtract the x's. Negative n over m is the slope. And then let's do the midpoint. Add the x's, divide by 2, add the y's, divide by 2. So the midpoint is m over 2, n over 2. So this makes this a right scalene triangle because all sides are different, and those two sides were perpendicular, forming a right angle. So you do have homework on Canvas. It is the 5-8 homework. Again, this is the last lesson for Chapter 5. There is already 2 reviews posted for you to start getting ready for your test. It will be open notes, so just organize yourself and just get ready for that test on Tuesday. But tonight's homework is 5-8. Homework over the weekend is the 1 chapter review, which is kind of long, and it's due Monday. You do have to turn it in. Any questions?